Hello, I'm Christian Pederson, and this is my 15-112 term project, Modeling Matter, educational software that teaches physics through the use of interactive sandbox simulations. So we'll start. So if you don't have any experience with this, there's two help buttons. Okay, the first one will tell you about the simulation you're in, what is it, what's the point of it, what is it modeling, and the second button will tell you what can you do. So what do the sliders do, what do the buttons do. So we begin in the particle zoo, which allows us to create gases of different elements. So we can make helium-argon gas. Okay, we make a mixture of all these. Okay, we can also add. So these are all monatomic, meaning that they are all composed of a single atom. We can also make diatomic molecules. Okay, so each of these has a different size, a different mass, a different radius. And so they all act differently. So you can see that helium pretty much moves the quickest. Helium and hydrogen move the quickest. Iodine, which is this purple, doesn't move that fast. And the collisions that they have are all accurate. They're all based on the momentum of the particles as they collide and the angle that they attack. So you can play around these and make all the different combinations of gases you like. The next simulation is an ideal gas. Okay, you can learn more about it in these buttons. It works very similar to the previous one. We can increase the particles, but we have two more parameters. We can actually increase the temperature. Okay, so now the particles are moving much faster, and we can actually decrease the volume of the box. So we can do that. So what's the point of this? Well, you read these and you'll learn more about pressure and ideal gases. But you can play around with these three parameters. You can, pick three particles, make them very cold and put them in a large box, small box, whatever you want. The third simulation models dipoles. So you start off with a dipole crystal. These are all electric dipoles. And we can create an external electric field. And you'll see that these all respond accordingly, and they have certain motion. In addition to making a stationary electric field, we can also make an alternate electric field. And so this is a sort of a simplified model of something. If you want to learn what that is, you can use these buttons and they'll tell you. But if I take this away, you can see that all these particles are now rotating and vibrating. Initially they were stationary. So we put energy into the system. And so what is that useful? What does that mean? Well, you can use these buttons. And the fourth and final simulation in my project is also my favorite. It allows you, it graphs the electron orbitals. And if you know anything about those, you know that there's some pretty cool shapes. So I'll just do my favorite one, which is the 3dz squared. So you click on this button, and a new window will open, which will actually display your the shape that you wanted. And you'll be able to spin it, rotate it, zoom in, zoom out. You can even make it full screen. Now you can align it with an axis. So here we are. So this is our shape. So you can see this is kind of like looks kind of like a peanut with like a donut around it. And so you can kind of move this. You can see it's a three-dimensional object. You can move it around. Like I said, you can pick an axis to orient it around. You can also make it full screen. And now it's full screen. Okay. So you can get